The directions say to evaluate the integral. The focus will be on the fundamental theorem of calculus, part 2. Let's take a look at the first example. Suppose I had the integral from -1 to 1 of x to the 100th power dx. So this is 1 over 101 x to the 101 evaluated from -1 up to 1. So if I replace x with 1, I get 1 over 101 times 1 to the 101. Then I go minus, and then I'm going to replace x with -1. And so I get 1 over 101 times -1 to the 101. So 1 to the 101 is 1. 1 times 1 over 101 is 1 over 101. So we get 1 over 101 minus. And then -1 to the 101 is -1 because 101 is odd. And then -1 times 1 over 101 is -1 over 101. So we get minus -1 over 101. And so when you subtract a negative, you add. So 1 over 101 plus 1 over 101 is 2 over 101. And so therefore, the integral from -1 to 1 of x to the 100 dx is equal to 2 over 101. And that's the answer to example 1. Let's take a look at example 2. Suppose I have the following. The integral from 1 to 9 of square root of x dx. So this is 2/3 x to the 3/2 evaluated from 1 to 9. So I'm going to replace x with 9 and get 2/3 times 9 to the 3/2. Then I go minus, and then I replace x with 1. So I get 2/3 times 1 to the 3/2. Now, down below, let's put a note here. 9 to the 3/2 is equal to the square root of 9 raised to the 3rd power. But this is 3 to the 3rd, which is 27. So this is 2/3 times 27. If you don't mind, I'm going to write this as 27 over 1 minus 2/3. Okay? So this is 54/3 minus 2/3. And we can say the following. The integral from 1 to 9 of square root of x dx is, now let's go back. 54/3 minus 2/3 is 52/3. So this is equal to 52 over 3. And that's example 2. Let's take a look at example 3. Suppose I had the integral from 1 to 8 of x to the -2/3 dx. Now, I'm going to come up here for a second. -2/3 plus 1 is -2/3 plus 3/3. Well, that's 1/3, okay? And so what I get is 3x to the 1/3 evaluated from 1 to 8. Now, I'm going to replace x with 8 and get 3 times 8 to the 1/3. Then I go minus, and then I replace x with 1 to get 3 times 1 to the 1/3. So this is equal to 3 times 8 to the 1/3. I'll come up here. 8 to the 1/3 is the cube root of 8. But the cube root of 8 is 2. So this is 3 times 2 minus 3 times 1. So this is equal to 3. Therefore, the integral from 1 to 8 of x to the negative 2/3 dx is equal to 3. And that's example 3. Let's take a look at example 4. Suppose I had the integral from pi over 6 up to pi of sine theta d theta. So this is negative cosine theta evaluated from pi over 6 up to pi. So what I'm going to do is I'm going to replace theta with pi to get negative cosine of pi. Then I go minus, and then I'm going to replace theta with pi over 6 to get negative cosine of pi over 6. So this is negative of negative 1, and then when you subtract a negative, you add. And then cosine of pi over 6 is square root of 3 over 2. Now, the opposite of negative 1 is 1. So this is 1 plus the square root of 3 over 2. But remember, 1 is equal to 2 over 2. So I could write this as 2 over 2 plus the square root of 3 over 2. But this is 2 plus the square root of 3 divided by 2. So what does that say? The integral from pi over 6 up to pi of sine theta d theta is equal to 2 plus the square root of 3 divided by 2. And that was example 4. Let's take a look at example 5. Suppose I had the integral from negative 5 to 5 of e dx. Remember that e is a number, right? It's just a number. So we could write this as ex evaluated from negative 5 to 5. Replace x with 5 to get 5e. Then I go minus, replace x with negative 5, and then I get negative 5e, right? Well, when you subtract a negative, you add. So this is 5e plus 5e. The answer is 10e. And so, therefore, the integral from negative 5 to 5 of e dx is equal to 10e. And that's example 5. Let's take a look at example 6. Suppose I had the integral from 1 to 3 of x squared plus 2x minus 4 dx. Now, for my taste, it's much easier to take this piece by piece. So what I do first is I'm going to look at the integral from 1 to 3 of x squared dx, and then add the integral from 1 to 3 of 2x dx, and subtract the integral from 1 to 3 of 4 dx. Okay? So it's really much easier if you can look at this one piece at a time. So I'm going to look at the integral from 1 to 3 of x squared dx first. So this is 1/3 x cubed evaluated from 1 to 3. Replace x with 3, and you get 3 cubed over 3. Replace x with 1, and you get 1 cubed over 3, but don't forget, we have to subtract. So this is 27 over 3 minus 1 over 3, which is 26 over 3. So we just took care of the first integral. Now look at the second integral. So we get the integral from 1 to 3 of 2x dx. So this is x squared evaluated from 1 to 3. You get 3 squared minus 1 squared. So notice, replace x with 3, replace 1 with 3, and subtract the results. So we always go from upper to lower, right? And so this is 9 minus 1, which is 8. We're almost done. So look, from here, I'm going to look at the integral from 1 to 3 of 4 dx. So this is 4x evaluated from 1 to 3, which is 4 times 3 minus 4 times 1, which is 12 minus 4, which is 8. Now what I get to do is put everything together. The integral from 1 to 3 of x squared plus 2x minus 4 dx is. So I get 26 thirds plus, now the second one is 8. Okay? And then I subtract 8. So do you guys understand what I'm doing? In other words, I'm taking the first number here. I'm adding the second number, right? Because remember, the integral from 1 to 3 of x squared dx, that represents a number. I'm adding the second number, and then I'm subtracting the third number. Okay, you're supposed to get numbers back. Okay. And so that's what I did here. The 8's go away, and we're left with 26 thirds. So, and that right there was example 6. So let's take a look at example 7. Suppose I had the integral from 0 to 1 of u plus 2 times u minus 3 du. So the first step in this is we have to multiply this out. Okay. Now, u times u is u squared. Then I'm going to go minus 3u plus 2u minus 6 du. So I FOILed that out, right? And so this is the integral from 0 to 1 of u squared minus u minus 6 du. Okay? Now, break this up. This is the integral from 0 to 1 of u squared du minus the integral from 0 to 1 of u du minus the integral from 0 to 1 of 6 du. If you break it up, it'll be easier to manage. Because now look, The integral from 0 to 1 of u squared du is 1/3 u cubed evaluated from 0 to 1. Replace u with 1, and I get 1/3. Then I go minus. Replace u with 0, I get 0. So this is 1/3. The integral from 0 to 1 of u du is 1/2 u squared, evaluated from 0 to 1. And so replace u with 1, I get 1/2. Replace u with 0, I get 0. And I subtract. And the answer is 1/2. Then I have the integral from 0 to 1 of, looks like 60u. And so this is 6u evaluated from 0 to 1. And then this is 6 minus 0, which is equal to 6. Now I get to put everything together. The integral from 0 to 1 of u squared minus u minus 6 du is 1/3 minus 1/2 minus 6. And if you don't mind, I'm going to write this as 6 over 1. The lowest common denominator is 6. And so this is equal to 2 over 6 minus 3 over 6 minus 36 over 6. Okay? And this is equal to negative 37 divided by 6. Therefore, the integral from 0 to 1 of u minus 3 times u plus 2 du is negative 37 divided by 6. And that was example 7. Let's take a look at example 8. Suppose I ask you the following. Suppose I had the integral from 0 up to 4 of 2 to the x dx. So this is 2 to the x over natural log of 2. Okay? So this is the function whose derivative is 2 to the x. And I'm going to evaluate this from 0 to 4. Replace x with 4, I get 16 over natural log of 2. Minus, then I'm going to replace x with 0. 2 to the 0 is 1. So I get 1 over natural log of 2. And when I subtract those, I get 15 over natural log of 2. So therefore, the integral from 0 to 4 of 2 to the x dx is 15 over natural log of 2. And that was example 8. Example 9. Suppose I had the integral from 0 to 1 of, this is a great question instructors like to give. Suppose I have x to the e plus e to the x dx. Remember that e is a number, okay? That's really important. So this is the integral from 0 to 1 of x to the e dx plus the integral from 0 to 1 of e to the x dx. So the integral from 0 to 1 of e to the x dx is e to the x evaluated from 0 to 1. Replace x with 1. E to the 1 is e, so I get e. Replace x with 0. E to the 0 is 1, so I get e minus 1. Now I get the integral from 0 to 1 of x to the e dx. You have to be careful in this because e is a number. And so here I get 1 over e plus 1 x to the e plus 1, evaluated from 0 to 1. Now, replace x with 1. 1 to the e plus 1 is 1. And then 1 over e plus 1 times 1 is 1 over e plus 1. And then I subtract 0, right? 0 to e plus 1 is 0. So you get 1 over e plus 1. Now we get to put it together. The integral from 0 to 1 of e to the x plus x to the e dx is e minus 1 plus 1 over e plus 1. Now, as an instructor, I would want a common denominator, okay? The common denominator is e plus 1. And so in the numerator, you're going to get e minus 1 times e plus 1 plus 1, which is e squared minus 1 plus 1 divided by e plus 1, which is e squared over e plus 1. So, therefore, the integral from 0 to 1 of e to the x plus x to the e dx is, if we go back, we get e squared over e plus 1. And let's do one more example for this video here. We'll call this example 10. Suppose I had the integral from 1/2 up to 1 over the square root of 2 of 4 over the square root of 1 minus x squared dx. So here I get 4 times the inverse sine of x evaluated from 1/2 up to 1 over the square root of 2. So this is 4 times arc sine of 1 over the square root of 2 minus 4 times arc sine of 1/2. Now, arc sine of 1 over square root of 2 is pi over 4. So this is 4 times pi over 4 minus arc sine of 1/2 is pi over 6. So we get 4 times pi over 6. So this is pi minus 2 pi over 3, which is equal to pi over 3. Therefore, the integral from 1/2 to 1 over square root of 2 of 4 over the square root of 1 minus x squared dx is pi over 3. And that'll do it for this video. And this is a video on the fundamental theorem of calculus, part 2, where we did 10 examples. Okay, thank you.